Hi guys. So today we are going to start talking about natural protein fibers. So we are still continuing on the natural fibers. We completed all the cellulosics. Now we are on protein fibers. And protein fibers are any fibers that come from animals. And we're going to talk about wool, especially. Wool is one of the major ones. And then specialty wool that comes from animals other than sheep. And there is also silk and spider silk we'll talk about. So let's first talk a little bit about protein fibers because they're all protein based. They all have similar properties. So the common characteristics are they're very resilient. They don't wrinkle easily. They are hygroscopic. And if you remember hygroscopic, that means it feels dry when you spill something on it. You know, even when it's wet, it feels dry. So it's that kind of absorbency characteristic. Protein fibers are very different from cellulosics in the way that, you know, when they're wet, they're actually weaker. They have lower tenacity. They are sensitive to certain detergents and oxidizing agents, so you can't just wash them in the washing machine the way we wash cotton and linen fabrics, for example. They are damaged by insects because they are protein. So insects love protein, especially moths, and they will eat it up. They are harmed by heat, agitation, sometimes hot water. So we will talk about those. And those are all the common characteristics. Every protein fiber has these. And they can be somewhat flame retardant, which means, you know, like, for example, if you're talking about sheep, when they get close to a flame, it doesn't catch fire like when we burn cotton or when we burn paper. Remember, paper, cotton, linen, they kind of burn the same way. They catch the flame really quickly. They smell like burned paper. And usually they're very easy to burn. But wool is somewhat flame retardant. It will still burn, but it won't be catching the flame as quickly as cotton does. We'll talk about wool that comes from sheep or lamb. Those are the most commonly used. And then there are specialty wools like wool that comes from camel, rabbits, llamas, alpacas, goats, and so on. And now we'll talk a little bit about silk, which comes from the silkworm. So protein fibers also have amino acids in the molecular chain. So there are amino groups and there are carboxyl groups in the molecules. Again, these are the specific characteristics that you would see in every protein fiber. Okay. We'll talk a little bit about sheep's wool. This is the hair of sheep or lamb, and they are staple fibers. They can only get as long as you let the hair grow on a sheep. And the length of the fiber will vary. The color will be different. I mean, think of this just as our hair. Our hair is in different colors. You know, there's wavy hair, there's smoother hair. So generally, wool fibers are the same way. They come in natural colors. They can be fine. They can be a little bit coarser. You know, the diameter of the fiber will change depending on the animal, depending on the kind. In wool, usually when we cut the hair of the sheep, we call it like shearing. What we get is this raw wool fiber that is usually very oily. And the oil comes from lanolin. Lanolin is a natural grease that wool has. And it is usually extracted from wool to clean it up, because otherwise it's going to be very greasy when you touch it if it's raw wool and not processed. So one of the major things you have to do is to clean wool. So you have to get that lanolin out of it. And this grease is actually used in pharmaceuticals as well, so it is something that we do use. Wool is usually sheared once a year. We do that using scissors, or sometimes they do it by injection and then the animal sheds the hair. Merino is probably the most valuable wool. And we'll talk a little bit about that. So the quality of wool depends on the fineness of the fibers, the length of the fiber, the color, the crimp, and the strength. And of course, you know, Australia is pretty popular with wool production because Ugg boots come from there and they make it out of wool. There are different kinds of wool. When we say raw wool, that is usually the wool that still has the grease, the lanolin in it. Pulled wool is removed from carcasses, dead animals. Clean or scoured wool is after you remove all the impurities. Recycled wool is wool that is reprocessed. So it is you know, if the wool was processed before or used before and you're recycling it, then we call it recycled wool. Lamb's wool is when the animal is less than 7 months old, and the younger the animal, the softer and the finer the yarns are going to be, the fibers are going to be. Virgin wool is wool that has never been used before or processed before, so it's not recycled, it's just virgin wool. And this is a scoured wool fiber. Scouring is a cleaning process. This is a deep cleaning of wool to get rid of all the impurities and also that lanolin, that grease. So this, you can see, is cleaned up wool fiber. When you look at the fiber morphology, you will see that it looks very similar to our hair. So it has cuticles, it has cortex. So if you look closely, this is how the scales look like on a wool fiber. And if you go into the details, you know, there are those two separate types of fibers in the center. There's this cortical cell, and then macrofibrils come out of it, and then the microfibrils. And then if you look at the molecular chains, I mean, it has this helix structure. And the main protein in wool is keratin. So most of the protein fibers that come from animals, especially wools and specialty wools, the main protein is keratin. This is the same protein that we have in our hair. So it has very strong similarities to our hair. They're usually 1 to 6 inches long. Merino fibers are usually about 1.5 to 5 inches, but they are the finest fibers, so better quality. The colors are naturally like this, like an off-white color before the bleach. And the fineness can be from 10 to 50 microns. So the resiliency of wool, which means it doesn't wrinkle, you know, it's not the kind of fiber that you would see that wrinkles a lot like linen, but that resiliency comes from that spiral helix structure and its crimp. So it has a crimp, and crimp is the waviness of the fiber. So generally wool fibers have this waviness. This is the molecular structure. So you can see the NH2, this is the amino group in the molecule, and the COOH is the carboxyl group. So this section is acidic, this section is basic, and this is the main unit in the wool fiber. They have a round cross section usually, but they do have those scales around it. So if you ever watched any shampoo commercials, you will see that our hair also has those scales on the outside surface, and wool is the same way. These are different kinds of wool. So mohair, you can see the longest one here, and these are the fiber diameters for each of them. So it goes about 0.1 millimeters in fineness. Merino wool is much finer than that. It's much smaller in diameter. This is alpaca, this is camel hair, this is Kashgora, Angora. So we're going to talk about each of these and what they mean in a little bit. Physically, as I said, it has crimp, and that crimp, that waviness, makes the fibers more cohesive. It gives more elasticity and loft to the fiber. They're naturally bicomponent fibers because of those two different parts in the cortex that I just showed you. You can see the light blue and the dark blue sections are those two different parts. That's why we call it a bicomponent fiber, because it takes different components from each section. One of the properties of wool is that it felts. Felting is something unique to wool, and it will happen when you put your wool sweater in the washing machine at high temperature, a lot of agitation and heat. It's going to, what it does actually is the scales kind of hold on to the fiber, and it just compacts the fiber, and that's called felting. And your sweater is going to shrink a lot because of that felting shrinkage. Okay. So just to compare a regular cellulosic fiber like flax fibers, these are very smooth fibers, no crimp, and wool has this wavy structure. It has a natural crimp to it. There are two kinds of wool. We categorize them based on quality. Worsted is actually the best quality, the better quality. Those are longer fibers, better uniformity in fiber length. Woolen yarns are generally made out of shorter wool fibers. So if you see worsted versus woolen, you know that worsted is actually the better quality wool, and woolen is made out of the shorter yarns. Color and luster really depends on the breed of the animal, because it is like hair. So the luster, the color, it will vary based on the animal. These are the scales. And again, the scales are what will make your skin irritated also. Some people are allergic to wool because of that, because those scales can be disturbing. And this is also the reason why wool fibers or wool fabrics felt or shrink so much, because those scales hang onto each other and hold the yarns more compact. This is the cross section. You can see it's pretty round. And if you look through the yarn or fiber, you can see the medulla in the middle. In some wool fibers, that medulla is thinner, and in some, it is a little bit thicker. These are cashmere wool fibers with the scales. These are naturally colored wool. You'll see all these different colors, black, there will be black sheep, brown sheep. So it's really like hair color. It will be different. But we usually bleach them if we want to dye them to brighter colors. These are a summary of all the properties of wool. One thing that will be different, I will actually point out the differences between cellulosic fibers and wool fibers a little bit. For example, silverfish doesn't damage wool, but moth damages wool because moth likes protein. It has exceptionally high resiliency, doesn't wrinkle as much. It bends easily, it's not very stiff. It is very resistant to acids compared to cellulosic fibers. And it is not damaged by microorganisms. And it does scorch when it's burned. And instead of turning into ashes, it kind of burns into like a bead, and then you can crush it. But it does smell pretty bad when you burn it. It smells like burnt hair. They are opaque. Light doesn't pass through them. They're not transparent type or translucent type of fibers. We talked about felting shrinkage, that that actually makes your fabrics shrink, and because of those scales on the surface. It has good shape retention in general if you don't agitate it, if you don't use a lot of heat. It does form pills very easily. Wool is a great insulator. It keeps you warm because of that crimp. The moisture properties are good. It is hydrophilic, but it also is hygroscopic, which means it absorbs moisture without making you feel wet. Stretch and recovery is good because of that coil structure, because of the crimp. It has good elastic recovery. It can be an allergen. It has low tenacity, low resistance to abrasion, and it can be weakened if it is exposed to sunlight for a long time. It can be dry cleaned, but I would recommend that you use Woolite or maybe a softener when you wash your wool fabrics so that the scales are soft enough that it doesn't felt. And you should wash them in cold temperatures, or usually hand washing is recommended for wool. Bleach, you have to be very careful because it can damage wool fabrics. This is an example of shrinkage. You know, this is the original size. This is after laundering. And it doesn't really require so much ironing because it doesn't wrinkle so much. So you should store them flat as much as possible, but you should also put some mothballs if you're storing it for the summer, because the moths will eat up your wool fibers. And after the end of summer, you might find your wool fabrics all with holes because of moth damage. The environmental impact of wool is still significant. I mean, even though it's a natural fiber, because the sheep are grazing all the time, it can cause soil erosion. The animal waste has to be disposed eventually. I mean, it does compost, but if you're breeding a lot of sheep, you know, this is something you have to think about. We use so much water and energy to clean and dye wool fibers. So that is a lot of chemicals that we put into the environment, but it is a renewable resource. So this is what we need to do. We need to know. We use them in apparel, furnishings, carpets, boots, obviously, and other industrial applications. Now let's talk about specialty wools. These are a little more expensive than sheep's wool. And so we use them as blends with other fibers. And some of these fibers are not easy to find. They're not available everywhere. And I'll talk about all of these. So let's talk about mohair first. Mohair is, again, don't mix this up with merino. Merino wool is still wool that comes from sheep, and it's a good quality wool, good quality sheep's wool. Mohair is not from the sheep. It comes from a goat. And the goat is called the Angora goat. So don't also mix this up with Angora or, Kashgora materials. So this is mohair. This is the goat hair. And it's a special goat that usually is found in South Africa, US, or Turkey. These are very resilient natural fibers. They're smoother. This is probably the cheapest of specialty wools, more expensive than sheep's wool, but less expensive than all the other specialty wools. And we use them in a lot of, other areas too. Kiviot, this is wool that comes from this animal. It's a very luxurious fiber, and you can use it as it is. It doesn't have as much lanolin, so it doesn't require too much cleaning. Angora, now again, this is Angora rabbit. Don't mix this up with the Angora goat. Remember, the goat wool is called mohair. The rabbit hair is called Angora, named after the rabbit's name. These are very fine, fluffy, soft fibers, and they are actually, they make really nice, soft sweaters. We use them a lot in apparel. So just remember Angora, when you see that, it's called, the rabbit hair. And sometimes in the label of your sweaters, you will actually see Angora rabbit hair, just to clarify. Camel's hair is also used for wool. It can be pretty lustrous. It's water repellent. It has good insulative properties. We use them in coats, jackets, scarves, sweaters. Cashmere, this comes from the cashmere goat, and it's a very soft fiber. It has no medulla, so the scales are so much finer that it doesn't felt as much as regular wool, and it doesn't irritate your skin as much because they're just so soft and smooth. And we also sometimes blend it with Angora and cashmere goats. So those two goats, when you mix them up, we get Cashgora fibers. Llama and alpaca are used a lot for their fibers, especially in South America. They're lustrous, they can be soft and fine depending on the breed, and they have a lot of natural colors. These animals are wild animals. These are very expensive because these are protected species. You can't find them easily, but these have very lustrous, fine, short fibers, very luxurious fibers. And they have this light cinnamon color. Yak is a fiber that comes from this large ox, and they're smooth and lustrous, and we use them in many different uses. All right, so these were all the animal hairs that come from different types of animals. Now, there is also a protein fiber that comes from silkworm. So I do want to talk a little bit about this. Silk is different from wool because, first of all, it comes from a silkworm, and the protein is different. In wool, the protein is keratin. In silk, the protein is actually called fibroin. It's a different type of protein. And we have, when we get silk, what happens with silk is that the silkworm has those two glands and fibers come out of it, or it extracts something, and as soon as it hits the air, it dries and becomes a fiber, and then it wraps itself with those fibers. So when you look at the cocoon, if you try to pull these fibers, you will see that eventually you will only get two filaments, which means silk is a filament fiber. It comes in miles and miles, it's very long, and it's the only filament fiber that is natural. So it's very important to take those two fibers without breaking any of them. And the process of getting the silk is called sericulture. And to do that, we usually boil the silk worm. Well, we boil the cocoons while the silkworm is in it, and the silkworm dies inside it once we boil it. And when we have the gum, there's a gum that holds it together. It's called sericin. And sometimes, we need to remove that. So if the sericin is still in there, it's called raw silk or silk in the gum. And then when we remove it, the process is called degumming silk. So to clean that up. Silkworms can be wild, but they can also be grown in a very protected environment. If you do that in a controlled environment, then we get cultivated silk, which is usually better quality silk. But if it is just wild silkworms, then we call it tussa or wild silk, and they're not as good quality in general. So if the cocoon breaks and the silkworm comes out, obviously you are breaking the fibers. So you no longer have just two fibers there. You'll have a lot of shorter staples. And that is not a very good quality silk. So we usually call them waste silk or silk noils. Now let's look at the fiber morphology. The surface is very smooth on silk. You can see the surface here. It has a pretty smooth surface. It reflects light, so it has a lot of luster to it. The cross-section is almost like a triangle. So you can see the cross-section here. It has this kind of shape. And these are the different types of silk. So silk noil is the staple fiber. This is when the cocoon breaks or silkworm breaks the cocoon and comes out. So all these fibers are now staple fibers. They're all broken into shorter fibers. This is the wild silk or tussa silk. And this is cultivated silk, which is when you have the silkworms in a controlled environment, you keep them protected, you feed them, usually mulberry leaves. And when it's in that controlled environment, you get better quality silk. This is skein of cultivated silk. And this is tussa silk noil fiber, like the wild silk. That's not very good quality, but it's also broken fibers. The properties of silk, you know, it is a strong fiber, especially for its fine diameter, because it's pretty fine. It has better resiliency than cellulosics, but not as good as wool. I mean, wool is probably the most resilient of natural fibers. What is unique about silk is, I mean, it is great for summer clothing. It does have good absorbency. It's hydrophilic, but it's not damaged by moth, silverfish, or any microorganisms. And when you burn it, you know, it does scorch at lower temperatures. Its sunlight resistance is kind of low. It can fade in color, and it has lower elongation than wool and lower elastic recovery than wool. So there are fine fibers, 1.25 denier per filament generally. The quality is based on how even the fibers are and how free they are from defects. Pure silk is 100% silk with absolutely no metallic compounds, metallic salts. So we generally put these metallic salts into silk. It's called weighing, and it gives you better covering power, better dye absorption, better drape on silk. But when you do the weighing, the silk ages faster and wrinkles more. So it's not a good thing, but it does make your fabric look better. It does have a luxurious appearance with high luster, fine, a little translucent, actually. Average resistance to wrinkling, good dimensional stability. They don't pill. Color damage can happen. They can lose their color, even with hairspray or deodorants. If you spray them around, you know, it will lose its color. So this is an example of color damage because of hairspray on a silk skirt. This is color damage after dry cleaning. And you can see some of those areas, especially with perspiration, you know, you can also lose color on silk. Silk is a very sensitive type of fiber. You have to be careful with silk. They don't irritate the skin. Raw silk and tussa silk is a little bit rough in texture, but other silks are a little, you know, smoother and nicer. They are very strong for their diameter. They have good resistance to abrasion in general, but finer silk fibers, because they're so fine, they can get damaged by rubbing, easily damaged by light. They can yellow or the colors will be lost. So this is the fading because of light exposure. So this is the original color. If you see the magnified video, this is the original color, and this is what it became after light exposure. Cleaning is kind of an issue because silk is a sensitive type of fiber. Usually you need to dry clean them or maybe hand wash. Some silk fabrics can be machine washed, but it's better to just be very gentle with silk materials. This is dry cleaning that faded the color. This is the original color. You can see how much it faded. You can iron them easily. You can store them. You know, the problem with silk is that if you sweat, the perspiration will damage your fabric. So you want to make sure it's clean before you store them. And you don't want to store them in an environment where it gets exposed to sunlight. This is, for example, an example of perspiration damage on silk. So it wasn't cleaned before they stored it. And when they took it out over time, you know, it was all damaged in the armhole area. You can see the satin silk wedding gown damaged. So this is silk. And I'll talk a little bit about spider silk. Spider silk is kind of a new fiber. We are not really using them a whole lot yet, but there are a lot of people doing research on spider silk. It has a different kind of protein. So the protein in silk was fibroin. In spider, it's called spidroin. It's a very elastic and hygroscopic type of fiber. It's so elastic and it is so fine, especially for its fine size. It's incredible how elastic it can be. Usually with something so fine, you would think that it would break really easily, but it doesn't. So when you look at protein fibers under the microscope, you can probably tell some wool fibers because of the scales, if you can see the scales. If you do the burn test, it's going to burn with a horrible smell. It will smell like burning hair. Sometimes the lanolin or the grease in the wool will also give a really terrible smell. And protein fibers are generally soluble in sodium hypochlorite, or chlorine bleach will dissolve the fibers. So this is what I had, and then let's go into our eye textiles. I should mention fur fibers are also protein fibers. So we also use minks, beavers, sheepdogs, you know, for fur. So this is a similar type of fiber, like a protein fiber. These are different types of animals. You know, again, we said Angora. Fibers come from the rabbit, alpaca, llama, sheep. And this is mohair, comes from the Angora goat. Talked about all of this in the slides. Let me show you a couple of pictures that we weren't able to see. This is a wool felt hat. Because of that felting property, you can actually use it to make products like this. These are wool rugs. We use them in carpets and rugs a lot, especially handmade ones. So this is a picture I showed you already. This is moth damage on wool. We talked about silk. These are different silk cocoons. This is Tussa silk. These are different types. These are broken, as you can see, so they're no longer the good quality ones. Dupioni, I think I did not mention this. This is silk reeled from cocoons that become tangled. So it's usually like more than one cocoon kind of put together. So this is different grades of silk. Like the Dupioni silk is a little bit different than the better quality silk. And this is a silk curtain that was damaged by exposure to sunlight. I mean, use silk in, you know, a lot of these applications. Sometimes luxury bed linens and comforters even, or interiors like area rugs, curtains, draperies, wall coverings, cushions, but mostly in apparel. This is a camisole made out of silk and spandex. So it's 7% spandex, 93% silk. These are silk ties. And this is a drapery fabric made with silk. And this is a sweater. So this is the magnified view, so you can see the knitted structure. This is the actual sweater. So this is 68% silk, 32% nylon. But you can see some damage because of rubbing. They were trying to remove a food spill on the fabric, but silk fibers are so sensitive to rubbing that it kind of damaged and wore off some of those fibers. So you can see this area that is damaged, and this is the area with no damage. And again, you can see a summary of all the different properties compared to cotton and flax. So the drape is low for cotton and flax. They're stiffer. For wool and silk, it can be varied. Wrinkle and crush resistance is very low for cotton and flax. Wool is very high. Silk is medium. Dimensional stability is low for cotton. Flax is average. Wool can be low because of that shrinkage, but silk is high. Moisture absorbance, I mean, they're all absorbents, they're all hydrophilic. This is differences in strength. Wool is a little bit lower in strength, and abrasion is low for most of them, except flax can be different. So this is all I have for protein fibers. Don't forget to complete your assignment after this course, and I will see you in our next class.